algebra class. I'm glad that I'm with you today via virtually. I'm sorry I couldn't be with you in person. And we're going to talk about elimination using addition and subtraction. And with that, I want you guys to find your vocabulary sheet that I've given to you, which looks like this. And we're going to take some notes first. And the first thing we're going to talk about is our definition, the description of what the elimination is. So I'm going to share another screen with you. We're going to talk about elimination. Then we're going to talk about tips for solving, and we're going to do some practice equations. I'm going to give you an assignment to do and turn in so that I can kind of see how your work is. We're going to do all this virtually. And I also want you to make a comment to answer one of the questions from our original vocabulary sheet, because I want you to understand, and then I want to understand what you actually know about this concept. So we're going to do lots of things today, and some of it's going to be virtually. So let's go ahead and prepare ourselves for the description. And of course, this sheet is going to go in your yellow folder. When it's all said and done, please don't make me look for it. So make sure that you put it in your yellow folder when we're finished. So the definition of elimination and what elimination is, so you can understand this from a math perspective, think about what you know about the word eliminate. When you eliminate something, you take it away. So in this case, we want to eliminate one of the variables. We want to eliminate either x, or we want to eliminate y. Okay, so the definition you need to write down is it's a method that involves eliminating a variable by combining the individual equations with a system of equations. So really what that means is you have two equations. We're looking at two equations, and we want to eliminate the x's or the y's in the equations. And you'll understand this more when you see the example. When you eliminate something, you want to take it away so that you can solve for one variable. And this is what it looks like. So we're going to go through. We're going to go ahead and go through the tips, and we're going to go through the equations. And then you'll understand this more. And we'll go through some of the examples so that you can kind of see how all this works. All right, so you should have put your definition in already in description. So you should have put that definition in your description. If you need to pause the video and go back so that you can rewrite it, then that's really okay. All right, so now let's talk about some tips for solving. The first thing that you want to look at, we're going to look at, your tips are going to be part of your examples. So tip number one, you want to look for a variable that you can eliminate. So you want to look to see if x will eliminate or y will eliminate. And in this case, you'll notice that y is what we're going to eliminate because we have a positive 4y and we have a negative 4y in this equation. And automatically, you're going to add these equations together because we want to combine both of the equations so that we just have one equation. We can do that because we can eliminate the y. And after you do the math, so in your tip section, you need to write down, you want to look for a variable that you can eliminate by adding. That's the easiest way. In your tips, write down, look for a variable that you can eliminate. In this case, it's y. So then it's just a matter of adding. So 9x plus 7x, the x's together are 16, and 30 plus 2 is 32. And then, of course, you divide it by 16. Whatever you do to one side, you do to the other. So x is equal to 2. That is your first tip. Find a variable that you can eliminate easily. In this case, it was the y. Our next tip involves subtracting, because you should notice your first tip is you can add them together. Your second tip is subtract. Now you need to be a little bit more detailed when you fill in these boxes. Don't just write add and don't just write subtract, because you have to really understand what this means. So in this case, you should notice in the second example that you have a positive 2x and a positive 2x. Well, that won't eliminate. That just gives you 4x's. So in this case, you want to subtract the whole equation. So you want to subtract the 2x, you want to subtract the 3y, and you want to subtract the 6. So you have to subtract all of them, not just the variable, the whole equation. So really what you're doing is you're using distribution for the negative sign on the outside. That's why they have parentheses. So now you can eliminate the 2x's. So the second tip is you need to subtract one of the equations so you can use elimination. And write that down so that you really understand it. These are your notes. So now you can eliminate the x's. So 5y, a positive 2x and a negative 2x now is no x's. Positive 5y and a negative 3y, you're left with 2y. And then 10 minus 6 is 4. And of course, you divide by 2, and y is equal to 2. So there's 2 tips. Now your final tip is a little bit more complicated because they want you to now, after you've, in this case, we solve for x in one of the equations, the first one, and then the second one we solve for y. Now this one they want you to solve for both variables. Now you'll notice that you can eliminate the x's in this equation, so you're going to add. But now they want you to solve for both after you have found the answer for x and y. So they want you to solve, after you've solved for one of the variables, they want you to go back and substitute it into the original equation. So this one's going to take a little bit more time. So negative 2x and a positive 2x is no x's anymore. Now you're left with 10y equals 20. So I just added it. I didn't have to subtract it and distribute. And then, of course, divide by 10, y equals 2. Now they want you to pick one of the equations and substitute the 2 in so that now you can solve for x. And I'm going to do it up in here so that we can do it. I'm going to pick the second equation. So I'm going to substitute 2 where I see y. So my equation in my second one is 2x plus 6 times 2, because that's what my y equals 7. 2x plus 12 equals 7. Now it's just a matter of algebra. Subtract 12 from both sides. I'm left with 2x equals negative 5. Negative 5. Don't forget your negative. Divide both sides by 2. X equals negative 5 halves, or negative 2.5 if you want to simplify the fraction. So now we've solved for x and for y. So in the first tip, you add them together to see if you can eliminate one variable. The next tip number 2, is if you can't do that, then subtract one of the equations, all of the x's, y's, and constants, so that you can eliminate a variable. And then in your last tip, after you've eliminated a variable, then you can solve for the other variable. So let's take a look at how you might use this in a real life example. And we're going to talk about a typical NHL hockey season. There's 1,271 games on the schedule for the regular season. And some of those games are a mix of intra-conference and inter-conference games. Intra-conference is where they play teams that are not in their division, and inter-conference are teams that they play in their division. And if you know anything about hockey or baseball or football, everyone's divided into a division. So what they're saying is that there are 311 more intra-conference games, so games outside of your conference, than there are games inside the conference. And they want to know, eventually they're going to solve, they want to know how many inter-conference games there are. So in this case, you always have 2 equations whenever you want to solve for a system of equations. So moving forward, you should remember that we're always going to use 2 equations. And generally, In this case, R is the same as X and T is the same as Y. You can use any variables that you want. And notice that you have a system of equations where you have total games. So intra-conference games plus inter-conference games equals all of your games. And then your second system of equations is your intra-conference games minus your inter-conference games. After you subtracted them equaled 311 because there were 311 more. In this case, you should notice very quickly that you can use elimination. Step one, you can just add them together to eliminate the t because you have a positive t in the first one and a negative t in the second one. And then after that, you can solve the system of equations so that you know how many inter-conference games that they are. So here's one real life example, and this is going to be important because later you're going to have a project that you're going to have to determine equations and you're going to have to figure out how many items of certain things that you have given some variables. So let's take a look at some examples, and we're going to go through this pretty quickly, and you can pause the video at any time so that you can really focus on and practice on how this is done. In our first example, you should notice that we have a system of equations, and right out of the gate, you should notice that we can eliminate the y's. And so in step one, they're going to eliminate the y's. So first you can we're going to add the equations. So after you've eliminated the y's, okay, and I'm going to do it up and down because it's easier for me to follow and see. They do it side to side, which is fine, but I always find it's easier to see what you're doing if you can visualize it up and down because it's nice and organized and everything's where it's supposed to be. So they want you to add them together. So this is going to eliminate, and you're left with 8x equals 16. And then, of course, divide both sides by 8, and you're left with x equals 2. Okay, now after you know that x equals 2, you'll notice in step 3 that they've substituted 2 so that now we can get our y variable. They substituted 2 where they see x. So we're just going to follow along. 3x plus 5y equals 11. They picked the top equation. 3 times 2 is 6 plus 5y equals 11. Subtract the constant from both sides. 5y equals 5 divided by 5, y is 1. So your ordered pair in this equation is x is 2 and y is 1. So we've solved for both x and y. We've used elimination. Okay, now I want you to try this one. I want you to use elimination and solve for x to begin with because hopefully you've noticed that you can eliminate the y's. And then after you get your x variable, choose one of the equations so that then you can solve for y. Pause the video, try doing it yourself, and then I'll show you the answer so you can check your answer. Okay, hopefully after you've done this, you've determined that your x is equal to negative 16 and your y was equal to negative 8. How did you do? Let's go ahead and check our next practice, the next way of doing it. So now we're going to use subtraction for elimination. That's our second example. Okay, so here are the steps involved to solving equations using subtraction. So if you notice up here, the 4 x's are the same, so we know that we're going to do something with the 4's. Step 1, we're going to write the system so that like terms with the same coefficients are aligned. And that just means you're going to rewrite it up and down. So that's what they did here. And then we're going to subtract one equation from the other, eliminating one of the variables. So I'm going to go ahead and eliminate the second equation. So I'm going to rewrite the equation. And then down below, I'm going to distribute my subtraction. So I'm going to change all the symbols. So I'm going to change my positive 4x to a negative 4x. I'm going to change my negative 2y to a positive 2y. And I'm going to change my positive 9 to a negative 9. So now I've distributed everything. So now I can eliminate my x's. 6y and 2y is 8y. And positive 8, negative 9 is negative 1. Divide both sides by 8. I know y equals negative 1/8. And then after I get my negative 1/8, I'm going to choose one of the equations and I'm going to substitute. I'm going to go ahead and substitute it for my second equation because I know 1/8 times 2 for me will be, no, I'm going to do it on the first one. So then you're going to substitute it in the first one. So I'm going to rewrite the equation 4x plus 6 times negative 1/8 equals 8. 4x plus negative 6/8, I'm going to simplify that to 3/4 equals 8. Then I'm going to add 3/4 to each side. So I'm left with, let me erase some of this stuff here. So I have some room. Okay, I'm dividing 4 from each side, so I'm adding 3/4 to each side, so I'm left with 4x equals 8 and 3/4. I don't have to change it to like terms because I'm just adding 3/4 to 8. Divide by 4, divide by 4. I would change this to a complex fraction, and then you guys should know how to do complex fractions. Let's go ahead. Oh, I'm scratching it out. Let's go ahead and erase all this up here so I have room to work. Okay, so I'm gonna change the complex fraction. I'm gonna change this to an improper. So 35/4 times 1/4. I'm sorry, times 4/1, because I have to flip it, keep it, flip it, do it. Eliminate these because they do eliminate each other. So x is equal to 35. Now this one was a little bit complicated, so let's see another example. Okay, you'll notice that 6x is what we want to eliminate. So we're going to have to subtract both sides. So I'm subtracting all variables. So this, make sure that you change this to a -6 as well. -5x and -6 and a -6y. So 30 minus 6 is 24. Let's go ahead and check our answers, which is correct. And then, of course, you would divide both sides by -2. So x equals -12. So now we know what -x is. Okay, let's go ahead and take a look at step 2. Let me erase all this. Now they want you to substitute that -12 for x in one of the equations. They picked 3x plus 6y equals 30. And then it's just algebra. So take a look at the steps. 3 times -12 is -36. Add 36 to both sides. You're left with 6y equals 66. Divided by 6, y is equal to 11. You can always go back and substitute both of them to make sure that you have the equation correct. And that's the tip that they're going to give you, the watch out tip, is you need to make sure that you get your positives and negatives correct, or else you won't have the same answer. So now you're going to try one. Okay, take a look at this equation. You'll notice that you're going to have to subtract one of the two equations because our negative 17x is in both of them. So pick one of the equations to subtract, work through it, and then you'll check your answer. Okay, hopefully you determined that x was equal to 2 and y was equal to 7. How are you doing? Okay, here's our final example. Now we're going to put this into real-world applications. So Maya and Kara build computers from parts and sell them to make a profit. Maya can build a computer in 0.9 hours, so not quite an hour, and Kara can build one in 1.2 hours. So Kara is a little bit slower than Maya. During a typical week, Maya and Kara spend a total of 15 hours building computers. One week, Maya builds twice as many computers and the two spend a total of 24 hours on their project. How many computers do Maya and Kara each make during a typical week? So we have a whole lot of things that we know about this. So let's determine our equations. First of all, you need to pick out important details. And you should go through it slowly. And what we're trying to find out is Maya's time spent and Kara's time spent to equal 15 hours in 1 week. And then in our second, then you have to put there how long it takes them to do it. So remember, Maya was 0.9 and Karen was 1.2, and it equaled 15 hours. And then in another week, Maya spent twice as much time, and they spent 24 hours. So our second equation is 2 times 0.9m because it was Maya who made twice as many, and then plus Kara's equals 24. So these are the two equations that you're going to use to solve how many Maya built and how many Kara built. And then all you do is put them together. Well, in this case, your like terms are the ones that you're going to eliminate are Kara's computers. And then you should notice that you have to subtract what you're supposed to do. So they've put together the equation for you. So let's take a look at how they solve it. Let me go ahead and get rid of this for you. Okay, then it's a matter of just algebra. 0.9m minus 2 of 0.9m's is just 0.9m. And then 1.2 plus 1.2 above, or minus 1.2 above, is 0.9m is equal to negative 9. And then they just divided and they got m equal 10. So Maya made 10 computers. So now they substituted in our second equation to see how many Kara built. So Maya was responsible for building 10 and Kara was responsible for building 5. And that's about twice as many because it said that Maya built twice as many as Kara. So you know that this makes sense because it is about twice as many. This is algebraically how you solve this. I want you to pay attention up here. I know that they didn't write it out for you, but they also subtracted this, and they also subtracted the 24 to get the negative 9. That's how they got 0.9m, and that's how they got negative 9. Hopefully this has helped you. We're going to practice some of these, and you're going to need to turn them into Google Classroom. Please look for your assignment on Google Classroom. I also have a question that I want you to answer. We're going to go back to our original screen from when we learned our vocabulary, and I want you to blog about this question. I want you to put it in the comments section of Google Classroom on this assignment. So in today's vocabulary, they asked a question. So let's take a look at question number 1. It says, you've learned that solving systems of equations by graphing will only give approximate solutions. Now you've learned that solving systems of equations by substituting works best when one equation is solved for one of the variables. When might you use elimination to solve a system of equations? So what do you notice about the equations, and why would you use elimination to solve it rather than graphing? I want you to go ahead and think about how you would answer that. What do you notice about the variables? When would this be a good idea to do it? And then that kind of goes with question number 2, so you don't have to answer 2 questions. Can you think of a way that you used elimination to solve linear equations? That goes along with number 1. Think about what you noticed about the variables and why you would use elimination rather than graphing. I look forward to seeing your answers. Complete your Google Classroom practice equations, and be ready for your next assignment tomorrow.